Hello, this is Ms. Nicholas. Today we're going to see how to graph logarithmic functions. This is notes 3.7. So first, parent log function is f of x equals log x. We already know that log functions are inverses of exponential functions. So here first I know that function 10 to the power of x can be graphed or just sketched here going through 1 like this, and log function, since it's inverse, 1 gonna come on x axis and look like this. First example, we have f of x equals log base 2 of x. So inverse function is 2x. Therefore, I need to first to find the table for f of x equals 2x. So let's just do the t-table. I can pick values -2, -1, 0, 1, 2. So right here, for my y values, 2 raised to the power of -2 is 1 over 4 or 0.25. 2 to the power of -1 is 1/2 or 0.5. 2 to the power of 0 is 1. 2 to the power of 1 is 2, and 2 squared is 4. Now for log function table of values, I simply switch x and y table. So x values are my y values from exponential table, and y values are corresponding x values. -1, 0, 1, 2. Now I'm ready to graph. So on x 0.25, my y value is -2. Gonna be somewhere very close to y-axis, and 0.5 is -1, x 1, y is 0 right here, x2, y is 1, and x4, y is 2. Let's connect the dots to get the curve. The graph is approaching y-axis. So this dotted green line is my asymptote. Let's take a look here on the right. We have to get domain, and I know domain are my x values can be all real numbers greater than 0. So I have x greater than 0. Y values, or the range, can be all real numbers. As x approaching positive infinity, f of x is also approaching positive infinity. When x is approaching 0, then f of x is approaching negative infinity on this end. X-intercept is 1, 0 on the graph, it's right there. And y, its asymptote is x equals 0, this vertical line. Let's take a look at second example. We have f of x log base 1/3 of x. So we need to have inverse of this function, which is f of x equals 1/3 to the power x. So to make the table, I'm going to use x and y values. Let's pick -2, -1, 0, 1, 2. When we plug in, instead of x, -2, it's going to come out 1 over 3 to the power of -2. So we need to switch the fraction, and we have 3 squared, which is 9, negative 1. When x is negative 1, we have y3. When x is 0, 1/3 to the power of 0 is 1. 1/3 to the power of 1 is the same as 1/3, or in decimal form is 1.3, repeating, and 1/3 to the power of 2 is 1/9. In decimal form, it's going to be 0.1. Now let's see to reverse the table and get a graph of our log function. Okay, so log 1/3. Now we know we have to inverse or switch x and y values. So x gonna be now 9, 3, 1.3, and 1. Corresponding y values, I'm gonna take it from this x, so it's negative 2, negative 1, 0, 1, 2. I'm ready to graph here. X is 9 and y is negative 2, so my value is here. My point 3, negative 1. I'll have point right here. 1, 0. Then I have 0.3, 1. I'm getting closer to y axis, and with 0.1 I'm on 2. As you see, this curve is getting closer to y axis. I can take all of the domain values with x greater than 0. Range can be all of my y values, so it's all real numbers. Now as x is getting closer to 0, f of x is getting closer to positive infinity. As x is getting closer or going to infinity, f of x is going to negative infinity. Y-intercept I have here as 1, 0, and asymptote is going to be x equals 0. Right here, my dashed line. This is the end of the notes. Please answer question 3 below this problem. Thank you.